We are now moving on to discuss life cycle costing, and I will often refer to this as LCCA. We're adding a second C here for the costing bit. As I mentioned in the LCA, or Life Cycle Assessment Introductory Lecture, LCCA, with the second C there, LCCA, Life Cycle Cost Analysis, has been used in engineering and economic planning disciplines for many years. This is strictly looking at the costs of a product, thing, or an action, so we're not looking at the environmental or social aspects, but we are considering costs over the entire life. So we are not just going with, this one has a lower purchase price, it must be the best buy. No, we're looking at the costs over the entire life. And as I said, LCCA was developed to track costs over the life cycle of infrastructure, etc. in the engineering world. It was developed to ensure that decision makers thought about our first costs, our initial costs, and our maintenance costs, our continual reoccurring costs over the years. LCCA is also useful for personal decisions. So what kind of car to buy? We'll look at that example. If you have taken an investment analysis course, this may already be familiar to you. In other domains, it may also be called total cost of ownership rather than life cycle cost. State departments of transportation, DOTs, have been using LCCA as a standardized tool to evaluate pavement for many years. And they've been promoting life cycle costs for a very long time. This is not new at all. And the cost basis of the LCCA formed a strong motivator as a public entity doing life cycles already, for which a standard could be built for energy and environmental analysis. So as this LCCA was already being used, it was already in place a great framework for adding on energy and environmental analysis. And we'll see that later on. The objectives of life cycle cost analysis are to identify costs that happen during the life of the project that are not the first or initial cost, to determine a total cost over the life cycle, the longer time frame, compare these costs during the lifetime to the initial cost. We'll see an example of doing that. And ideally, we want to discount all future costs to the present for comparison. Discounting is important, especially for projects, items, or actions with a longer time frame. Discounting incorporates the effects of inflation, just the fact that your dollar today will not buy as much as $1 in 10 years. And ideally, with LCCA, we compare our costs to the total benefits to determine whether our action or our project is worthwhile. So the steps of an LCCA is, first of all, to establish design alternatives, including the status quo. So what the status quo is a term that I'll use often. This is what we are currently doing. So LCCA is usually completed when there are 2 or more options. Sometimes one of the options is just sticking with what is currently happening, our status quo. The second step is to determine the activity timing. So we need to think about what is going to occur during the lifetime of our options or our product. What things or activities could require costs over the lifetime? Then we need to, 3, estimate costs, the owner costs and the user costs. Owner costs are costs that are paid for by the person or the entity that is in charge or that manages or owns the option or item. Whereas user costs, these would be incurred by the individuals that are using the item or that have some tangential role in the project or action. So are there any costs that external users could incur? Number 4, we compute life cycle costs with discounting, and I'll show you how to discount future costs. And then 5, we look at the results. We analyze the results. What do they mean? And we need to, at this point, make a decision on which option is best based on costs. So again, this is a cost analysis. We're basing our final analysis on costs.